talk about option and result. The layout of this talk, we'll start with a little introduction. We'll talk about option and result. And then what we're going to spend a lot of time talking about is how you can use option for control flow in your programs. So we'll talk about map and then how those differ. And then I'm actually going to spend some time propagandizing because Ashley Williams is one of my favorite technical speakers. Cool, someone got that. And then we'll talk about filter and the or and or else methods, how those differ, unwrapping values, and then result, and how this is kind of distinct but similar to option. And then there's a collect trick that I think is the coolest thing that you can do. And then we'll conclude with more propaganda, of course. So I should say hi before we dive into things. I'm a dog on the internet, and you probably know me as this dog. That's me, hi. So that's my Twitter. You should come say hi and all that. I'm also a person, actually in real life. So this is me. I'm a musician in my spare time, and I'm an engineer by day. So I started using Rust in early 2018. And before that, I actually hadn't really worked in a systems language before. I'd written C in college, but that was kind of it. And moreover, I hadn't really written in a pure functional language, so I hadn't written in OCaml or Haskell. And I was coming from JavaScript primarily. And that's kind of difficult. I remember some pain points that I ran into that I wanted to kind of help other people not run into. So it was really exciting seeing in the build-up to this conference that there were a few people that were totally new to Rust that were coming. So this is totally for you. Yeah, so let's get into it. I feel this is obligatory, but this is a quote from the Rust programming language book that talks about how Rust is a language fundamentally about empowerment and how it empowers you to go program in new domains that you hadn't worked in before. That's super critical to me, and I think the community also plays a large role in that. So that was kind of what led me to try writing in Rust, writing code in Rust. And that's really nice because when you're moving into these new domains, there's all these things that you're slightly unsure about, and you have this safety net that the compiler can kind of check some of your code and say, hey, it looks like you're not doing this properly, which in other languages, C, you don't get. And that's definitely really nice, but there's also a lot of these conceptual things that are in Rust that are borrowed from OCaml and Haskell. I always mention F# because it's near and dear to my heart, this just strange language where you write functional code but you use .NET APIs. It's such a gem. But yeah, so some of this stuff is very new and fun. You get pattern matching, and that's super fun. You get type classes. We call them traits, but they're fun and cool. And you get monads, which I don't really. As a side note, I know someone that has a joke that says if you understand monads, you can't explain them anymore. So I'm not going to try and explain them, because I won't be able to explain them. But yeah, so you have the safety net, but you're not really always able to get advice from the compiler about conceptually what you should be doing. How should you be structuring your code, and how should you be, what are good and bad decisions in a language where, you don't have null, which I'm kind of lying to you about there, but you don't have runtime exceptions, and you don't have class inheritance, which can feel really confusing and intimidating at first. And yeah, that first thing's a lie. There's people that do C ABI stuff or something that are haha, but that's different. So So yeah, like how do we work with all these things? And a lot of it ends up being with option and result, which are these generic types. So they have like type arguments, and yeah, like we can look at how they're implemented. This usually is something you end up seeing pretty soon once you start writing Rust. It's like an enum that could be none or some value t. And this could be typed as whatever. This could be an optional integer, string, so on. And results very similar. You have this OK value, which looks kind of similar. But in addition, you have an error. And so usually, error is something that could have gone wrong. And that's like a way to represent like, hey, you tried to open a file that doesn't exist, or this or that. If you've written Haskell, you would know this is like the maybe monad and the error monad. I am not super familiar with Haskell, so don't like shoot me down if I'm like subtly wrong here. But conceptually, these come from other places. I think about this quote a lot too. It's like so funny to me that this person invented null and is like, this is the worst thing ever. I would have never done this. Because if I had invented like a thing that we all like in this room just take for granted, I'd be like, I'm the null girl, like what's up? That was me. And he's like very upset about having done this. So yeah, like we use types, and that definitely at first was like kind of confusing, or if not confusing, like a quandary to consider. Like why would we use types? And yeah, as the next line says, if we're using types for these things, the compiler can actually check that we don't reference a null value, or we don't, that we actually handle all the errors in our programs. And the real thing that I like get really pumped about is that if these are types, they also have methods that we can use to describe control flow patterns that are very common. And this, I think, is where the really good stuff is. Yeah, so let's also disambiguate quickly that we're not talking about, when we say like map and filter, we're not talking about the same map and filter that you might already know if you've worked with like functional techniques for like arrays or vectors. This is also totally kind of a lie, but intuitively, these are not quite the same. If you're interested, go look up functors, they're interesting. So like code like this, where you have an array, and you iterate over it, and you map these values. We don't mean that. We mean this other thing, option map. And there's some code in there that does stuff, and we'll get to what it is and why this is useful. And that's coming up next. But filter, it's the same thing. We're not talking about like, hey, take this array and give me the values that are positive. We're talking about option filter and result filter, which are similar if you look at the definitions for them, but distinct from like an intuitive standpoint. Like, what does this actually like represent? So sometimes it helps me to like think about this like in English language, which I tried to write out. If we map like a collection, we're applying a function to each element in the collection. And if we're mapping over an optional value, we get a new option by applying a function to the wrapped value if it does exist. Filter is kind of a similar thing, but as soon as I was writing this out, I was like, this is just a lot of words, and it like doesn't really help as much as like I thought. So I feel like it helps a lot to just look at an example, and so we'll start with map. Cool, so this was the function we were looking at before. It takes and consumes self, and it takes a function f as a parameter that takes some value t and returns u, and this would be used on like an option of type t. So we're cooking cupcakes, and we want some like whipped egg whites. And so we have these structs. These are just like empty structures. We're kind of just going to play with the type system here. And sorry, by the way, if the code examples are a little small, like feel free to come up front. You know, projectors, what can you do? But yeah, so like we can convert between an egg to an egg white and an egg white to whipped egg whites. And again, we're just playing with type systems here. So like we're just basically just giving you an egg white if you convert an egg to an egg white and so on. So here's like some example code. And we have this function separate up at the top that takes an egg and returns an optional egg white. We could imagine like, hey, we messed this up, we didn't separate it correctly, and now we have nothing. Again, this is kind of type system stuff, and I'm trying to fit stuff on a slide, so it's just returning some egg and convert it. And down there in main, we have like, you know, hey, we have this egg, now we have egg whites and we separate it, and then we might match on whisking the egg whites. And if we get some egg whites back, if we do have some egg whites, then we should whisk it. And if we don't, then we should just panic. And this is like a good start, and definitely like kind of how I started to like poke at things when I was starting out, you know, trying to understand how you would work with an option. But that panics, and so what you could do instead is just return none in the none case. And that's nice, and now we do have an option at the end, which is something we'd have to unwrap or what have you, but it means like, hey, we do have like a program that won't crash sometimes, which is always a good start. But this is also like a lot of noise just to like apply a function in there. You know, we're like matching on egg whites, and then if it's some egg whites, then we're returning some whisk egg whites. And the important part here is whisk, and that's really easy to kind of gloss past. So that's like what map is actually for. If you look on line 12, now we can just say egg whites.map and then pass whisk. In a lot of these examples, I'm using this like shortened form. I think it's called eta reduction. But it's basically just when the signatures line up like this, you don't have to say like egg in a closure goes to whisk. So yeah, that's like literally what map is defined as. Like if you go look in the implementation of it, it's like one match statement. Which was like sort of surprising to me. I was like, oh, there's probably all these edge cases, and it's like, no, this is like a match statement. And if you have some x, then you return some f of x. So this is just a nice way to abstract over like some common control flow. This is a drawing kind of it that might help. Pretend the cupcake is in a box, because you can't really easily draw a cupcake in a box. That also looks cute. But if we have an empty box, then we're just like, great, okay, sure, pass that along. And if we do have a cupcake, we take it out of the box, put some sprinkles on it, and put it back in the box, and now it's happy and it has sprinkles. Adorable. So this is a different example, but and then is related, and there's definitely like many moments where I was like, why? How does this differ, and what's the point? So the spoiler, just like off the top, looking at the function signature, is that down there in the where clause, this function returns an option. And so there's a lot of cases where you might have some optional value, and you want to do something with it that would also return an option. And so if our whisk function also returns an option, returning to this like egg example, we'd see like when we run this at this point, like using map, we'd have some whipped egg whites. And that's very clunky, and as soon as you run into this, you're like, why do I have to unwrap this twice? This is kind of silly. And we could, you know, pull this back out into a match statement, and we could have what we want at the end if we don't wrap that in sum. So if we match on egg whites, and we do have some egg whites, and we just whisk the egg whites and get back whatever comes from there, then this works as we would like. And we can even like kind of squish this down more and end up with like this nice concise thing on one line. And this is sort of cutting down a ton of noise that we had before into just like this one nice like, hey, separate this egg and then whisk it. And it reads left to right, it's very declarative. And if something were to go wrong, we're also not going to freak out and panic. And so yeah, that's like, it's another kind of function method that's like a single match statement. And when you see it like this, it's kind of intuitive, and you might even wonder, like, why is this good? And I think this brings up something that I do want to warn about, or really propagandize about. So using this kind of stuff, using like these applicative function, monadic, blah, 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 smart people words, techniques to represent your control flow is really great, and you can write things that are very concise. But this can also really quickly come at the expense of readability. And that starts to be a problem if you go too far in that direction. So you should be using these to abstract away control flow that's irrelevant to important concepts in your code. And that way you can read things and just see what's really important. This is what I'm really trying to get at, is that code is actually about communicating ideas to other people. Yes, it goes and talks to a computer, but it's really, you're trying to write something that another person can come along and see and work with. All right, so back to programming. We'll talk about option filter. It's another function that, in this case, it calls the function parameter predicate, and this should return a bool. We'll use this to, like, in our example, make a cupcake that's allergen-free. So we have some ingredients, and we have almonds and flour and frosting. And this part's a little hard to read, forgive me, but we have this trait ingredient, and that has this function allergen safe, and that returns some bool. And we can implement this trait for all of our different ingredients, and almonds are not allergen safe. There's people that might have nut allergies. If you're in the room and you have a gluten allergy, like I see you, I'm just, it's a talk slide, and I didn't have a better example.
Gluten-free flour.
There we go, yeah, gluten-free flour, we'll pretend it's that, and this is definitely allergen safe. So we can imagine the situation where we have this structure and ingredients with a bunch of different members that are all these options. And we might have I have a default implementation here just for like the sake of example, and getting us somewhere where we have some of these set to some and some of them are set to none. But this kind of pattern comes up a lot if you're using the builder pattern, which is out of scope, but happens a lot in like library code and stuff. But if we wanted to filter this almonds thing out, if it is allergen, if it's not allergen safe, we'd have to like unwrap it, and then we have to apply this we have to call this method on it, and then we can see whether or not that actually returns true, and only in that case should we keep the almonds. And this is a ton of like noise. It looks terrible, and I couldn't even fit all three of the variables. Like really quickly, this just blows up. And you could use like match guards, and that's kind of nice. You could say like some almonds if the almonds are allergen safe, but that still kind of sucks. And using filter takes care of a lot of this, and we can do this all like multiple times in a row for different values in like 3 lines, and it still reads like you can see what it's trying to communicate to you here. Arguably a lot cleaner than this like big nested if let, if something. This is just saying like, hey, if it's allergen safe, we should keep this. And yeah, so like that's what filter is doing. It's taking some piece of logic, and within this like template control flow, it's going to call this function that you've given it, and then only return some x if it passes that. So here's like another cute little drawing. if the cupcake is there and it's looking real happy, like that's great, send it out, ship it. This other one's looking like a little more reserved, so we're gonna hang on and just send an empty box forward. And if there's no cupcake to begin with, then we just like don't have a cupcake to filter with. So yeah, this is the next method that I think is actually really useful, or else. And again, it's a thing that takes a function. You're noticing a pattern here. These are all like very similar, kind of like in their interfaces. What they're actually like doing with the function you give it is kind of what's interesting. So you might ask, why not option or? And not almost isn't the right word there. Like these are just different things for different situations. Or is very similar, but it takes an option, whereas this takes a function. And that seems like a small difference, but if we're in this kind of situation where we have this function foo, forgive me by the way, this was a point where I just could not, I was not very hungry. I couldn't think of cupcake examples. I saw the slides like a day later and I was like, oh shoot, okay, yeah, I forgot the cupcake metaphors. But yeah, so this returns none, and down there in main we're saying like, hey, let result be the result of like call foo, or if that's none, set it to some value 2. And then we can unwrap that, we can print it, we're all happy. But if we outline that like into some other function down the road, suddenly we're calling both of these functions. So foo is called and bar is called, even when foo did return some value. And that's because it's expecting an option. So when it gets a function or some expression that resolves to an option, it has to do that work. And so or else exists for these kinds of situations where like you don't actually want to run that whole computation. You should just do that if you end up with none like in the first place. So this would only call foo, and we unwrap 1 and we're all happy. And yeah, it's kind of simple enough once you like look at it, but you know, or is really just like, hey, match on self, and if I have some value, then just return myself, and if I don't, then pass along that option B that I was given. And or else is like the same thing, just with a function. Unwrapping is like arguably something you could do first. You end up like, I feel like this is most people's like first question when they're trying to write Rust. It's really great when it works. You've got this box, you open it, you're like, I got a cool cupcake, it's got these cool eyes, everyone's excited. And when it didn't work, it can be very like, whoa, this really freaked out, what's going on? And then you run Rust backtrace, and like you're, you know, it's a big error. So sometimes, I feel like it's not evangelized enough, or like not mentioned sometimes, but you can use this other thing called expect, and you can put some kind of string there. There is much controversy about how you should structure those strings, but you can put something there. And when you panic, you'll actually get like, hey, I panicked at a value that exists, which in a very trivial example like this isn't that useful, but there's situations where like sometimes it's very nice to just have a string that you can grep for somewhere and really quickly jump to what went wrong. Unwrap or else, another quick little useful tool to know about. And notably the function that it takes should give you a value t. It shouldn't give you an option. But in these earlier examples we were looking at, we could call foo and then say or else bar and then unwrap it. But we could also set this up in a way where if bar was just giving us a number, we can just say, hey, call foo and unwrap that, or else call bar. And this, depending on your situation and style, but like this can read a lot more declaratively, like from left to right. since bar is really only needed when you end up with a situation where food return none. And yeah, like that's pretty much the premise is like, hey, when you're looking at the implementation of this, like, hey, if I have some value x, return that value x, and if I don't, call that function f. And it's only called when we don't have a value wrapped up. So control flow with result, it exposes all the same kind of methods. There's some nuance here and there. So let's talk about result map. Just kidding, time is like very finite. Yeah, I'm sure that like a pig is, ugh. I wouldn't do that to you all. And the good news is like you already get it. These, like when we were looking at their definitions earlier, they're like very similar. The only real difference is that we have none, and in result we have error of some value e. But the OK and some are basically analogous. So you totally already get it, I promise. I'm not going to go through all those examples, but like you would see them when you're working with the result and you very quickly pick it up, I promise you. You can kind of imagine an option as a result where the E type is just unit or empty. I'm sure you could probably even try and write it that way, but everyone would be very confused. And yeah, all of these methods are like pretty much identical, except instead of saying some value t, you'll say OK value t. And yeah, like conceptually, this starts to fall in place very quickly. But before we like just gloss over results and just pretend, it is identical, there are some really cool things that you can do. And I want to share this like collect trick. So if we have like cupcakes and an order is just like a vector of temperatures because we're running a very esoteric, not very user-friendly bakery where you order cupcakes by saying, please bake this at 250 degrees. I'm sure there's someone out there that wants that, but there's also no flavors. This is just like a plain cupcake, unfrosted. But you get to pick what temperature it's baked at, which is great. So we have this bake function, and if they've asked to bake it, at like 100 degrees, nothing's actually going to like bake properly. It's going to be too cold. And if it's greater than 300, then we just burn it. I don't know if these were actually accurate to cupcakes, but whatever. But yeah, so we might have this function that's processing an order, and this looks kind of heinous, like it's a lot of stuff. But the premise is that it's like this thing that I feel like we do a lot when we're trying to work with a collection of inputs and have this process for each of these elements that could fail, which is like we want to keep going through these, and at any point if we see a failure, we should just exit, we should stop early, we shouldn't keep trying to go forward. And that I feel like is very common, and this is a ton of noise for something like that. Like really, again, despite all of this like stuff happening, we really just care that we're calling a bake, which is like there on line 4, and you kind of have to like squint at this for a second to see that. So we'll come back to that in a moment, but imagine we have this main function, and we have this vector of temperatures, and we should see when we run this like too cold, because 199 happens before 350. If we get to that error, we should stop. We shouldn't keep going. And so this would work, it'd be fine. But we can also use the collect method and iterators to just say like, hey, iterate through these temperatures, map each one, use like map to just like call bake on it, and we'll end up with this like vector of results. But when you can also collect this into a result of a vector, which is really nice. Right now, by the way, this is like in a function with a type signature, so collect just knows what it's going to do. A lot of times if you're calling this within the context of like a longer function or what have you, you might have to turbo fish it, which is when you like do the little 2 colons and then you give it a type argument. And usually you can just elide the types inside altogether, but you just need to let it know like, hey, I'm trying to get a result of a vector. And it will work fine. Cool. So let's wrap up, by which I mean continue to propagandize. And I want to talk about life, like the game of life, not like life that I know. This is an implementation of the game of life in this array-based language called K, which I think is like truly a special language. My friend Phoebe wrote this for me for this talk, and I just saw it and was like, this is beautiful. This is art. And you know, this is like very, very terse. It's doing what like a game of life implementation often is like a little bit of code. It's not like huge, but it's like a good amount. And this does it all in one line, which you might hate, and you might look at this and say like, this is horrible. And other people look at it and say, this is beautiful, and it encapsulates the whole problem in a single line. And echoing what I was saying earlier about how code is really about communicating ideas to other people. Like you could use any language, but you're choosing as a team or a group of people to work in a similar language or the same language, and work together and communicate and write code and review each other's code. And so all the stuff that I've talked to you about today is a different way to communicate. It's not a better way to communicate. It's very easy to, you know, feel very smart when you write these like functional chains and say like, you are, you know, this enlightened programmer that knows so many things and you should just raise yourself to my level. But it's not that. It's just a different way to talk to people. So how you build a better cupcake, returning to this slide again, it's great if you can represent a bunch of boilerplate things very concisely. But really you want to write code with a concise style. So if code around you in your code base doesn't also do that, you might not actually want to do this because other people coming along and seeing it are going to be kind of thrown off for a second. You should write code that other people can understand and maintain. And these techniques are great, but you should decide if you want to use them by talking to them. Thanks.